Zia, thank you very much. Thank you for ending on a very positive note as well. I would like to give everybody an opportunity to introduce themselves on the panel before we get started. We do have their names up there as well, but Zia, if you just wouldn't mind starting us again.
Hey, Zia Mehrabi from the University of Colorado Boulder.
Hi, Chloé Smith. I'm a Swiss lawyer, but now currently doing research at UC Berkeley at the School of Law.
Hi everyone, Gaurav Sant. I'm a professor of engineering at UCLA.
Hi everybody, I'm Groh. I'm a chemist and CTO of KUORI.
Thank you all very much. Chloé, I'd like to start with you because you do have the law background, and we just saw some really interesting things from Zia about how actionable this is. You know, there's evidence for it. It can be done. And, you know, I can't think of a more American concept than more is better. And you have evidence to show that. But there's not specifically laws and policy to help to put that into place. So what does the environment look like for the kind of work that Zia is doing, and like, what do you think might have to change to make his scale and his lab's scale, this evidence they've shown? How do we actually bring this about?
Yeah, thank you. Thank you for this excellent presentation. I think several points here. There's policy, there's litigation. Let me speak of maybe the second point in terms of litigation. That we've seen more and more environmental litigation, more and more climate litigation as well across the world. One that is dear to my heart and that's very close to some of the research that Zia's done with his team is working with an indigenous population in Alaska and using ecological and indigenous knowledge to inform a complaint that we filed to the UN Special Rapporteur on Toxics and Human Rights regarding two toxic sites, former military defense sites that have completely intoxicated an island in the Bering Sea due to heavy metal. There's heavy metals and spread everywhere on the island, and people are affected in their health, and the whole environment is affected, and the whole ecosystem. So I think that this project brings a lot of similarities in some of Zia's work, in the sense that there was community-based participatory research that was done for 20 years to be able to use that evidence to inform the litigation. Or it's not pure litigation, it's more trying to get the UN involved and getting international pressure and international attention to a small island in the Bering Sea. But I think that this is one of the ways in which one of the solutions, and really to bring people that are most affected in the forefront of the issues. And then there's policy and informing policy. And I think some of the work that Zia presented, getting stakeholders together to work across all different continents, working, I think, together in collaboration before the rules are made, before the policy is actually made, try to get them in the room, get the communities, get the scientists, get the regulators, get the industries, get the startups in the room before the rules and the policy are made, I think is very important, and is also what we try to do at UC Berkeley at the Center for Law, Energy, the Environment, is to organize some of these convenings and really work before policy comes and becomes law. And sometimes analyze those policies and says, okay, how can we change them, and how could we tweak them a little bit before there are other issues. Thank you.
And that's slow going. It's just as important. Like the science can be slow going and the policy change can be slow going. But then we get to engineers. And Gaurav, I wanted to ask you about this because, you know, you see things from an engineer's point of view. And, you know, you had talked a little bit about big swings, you know, about like how it's important to do things like this. So certainly the policy is important. Community engagement is important. But then there's the technical aspects of what Zia's work is doing. And I'm just wondering, as you saw Zia's work and as you think about life as an engineer, what are the practicalities that you see that you think the world is ready for, or that policy needs to get us ready for?
Great questions. These are really big questions. I want to say that when I was a little boy, I spent a lot of time having my little urban farms here. So growing tomatoes and Kenyan bird's eye chilies was sort of what I was really into. But my urban farming aside, I think a couple of thoughts, right? So I think first of all, decarbonization at large is going to be much more expensive and it's going to take longer than we think. And I think that humility is sort of important to absorb. And that's not to mean that you give up on aspiration or ambition, but I think realism is really important. Comment number one. Comment number two, these numbers are thrown around very often, right? We release, give or take, about 40 billion tons of carbon dioxide into the atmosphere every year. And, humans have done a lot, right? By any standards, we've sort of, come out of the trees, come onto land, sort of literally taken over the world. But these material flows are larger than anything else that we've ever done, right? There's no precedent for it. And so when we really take a step back and say, how do we plan to reverse that emissions flow? That really requires some very hard thinking. That's the first comment. The second comment, which I think is really important to focus on, which I think is fundamental to the discourse, it's all of the things that we actually take for granted that are actually responsible for these material flows, right? So simple example, I train to be a cement chemist. Believe it or not, people go to school for things like this. The production of cement, steel, and sort of all of the fundamentals that underpin our society is in fact what corresponds to really these very large emissions profiles. And what that really means is, when we've gone to a point where we don't think about decarbonization from the bottom up. We often have a tendency to think of it top down. But in fact, it's actually the bottom that needs to transform. And the transformation of this bottom is very, very hard, because you've got industrial sectors that have taken 200 years to come to maturity. We've put lots of steel and concrete in the ground, figuratively and literally. And imagining how we're going to do that differently is just very hard and very slow, right? So, the only other sector that may be sort of more primitive on a global scale is actually agriculture, right? And that's actually really important for two reasons. Number one, you need to change manufacturing and processing systems, but you fundamentally need to change human mindsets. Very hard to do, right? Now, as an engineer, I spend lots of time thinking about these things, right? So far I've said nothing about engineering. But what's important to really point out here is to think about what the engineering dimension looks like. Really requires realism around transforming the state of the art with three sort of basis sets in mind, right? The first is we cannot imagine that we're going to strand existing sectors and simply build new sectors overnight. This is a false premise, number one. Number two, indeed, while this will happen in due course, we need to think about this concept around net present value parity. I offer this example to people very often. We're hanging out in a really nice space in San Francisco. We're all in the United States. We all have a per capita footprint of about 15 tons of CO2 per year. If a really innovative company said to you, pay me $1,000 per ton of your emissions footprint, and I can, make this all go away, I doubt this audience is going to hand over $15,000 per person, right? Now, that's an important question because the economic realization behind the fact that we won't impoverish the world to save it is really quite important, which really leads to asking the question, how long will it take? How much will it cost? And that sets the engineering dimension of the problem, right? So, I look at engineering, I look at technology as sort of the lever that you use to make things more affordable and better, both. And I think that premise is fundamental to how we need to think about what's the role of engineering at large.
Very good, thank you. And how long is it going to take? How much is it going to cost? This goes exactly into what I wanted to talk to Arthur about, because KUORI is your third startup, is that correct?
Yes.
Yes. So you are intimately aware of how long it takes to do things, how long it takes to do the money to things, how to get an audience or a customer base involved in that. Would love to hear your thoughts on what you've heard already now in terms of the policy, in terms of the engineering, in terms of what Zia's lab is doing. From someone so experienced in startups as yourself, what have we not thought of yet, or what have we not considered in trying to make this happen?
I think we covered already a lot of the essential questions, and there's a lot of research around which is super interesting, which shows us that we need to go this pathway, but from my experience in the industry, it always comes back to money. And this is sadly the truth. You need to be more efficient, more viable, it needs to be cheaper. And the focus is too often on short-term goals. So regarding the publication of Zia, there is evidence that you are not decreasing the yields. And this needs to be displayed transparently and taught to the farmers that there is no risk of reducing your income, of reducing the yields. There's rather the opportunity to get a larger outcome, beneficial influence on the soil fertility and so on. And for us at KUORI, it's essential to have this research also accessible. This gives us, so we produce bio-based materials, so we need to rely on agriculture and resources supplied by agriculture. And to choose the right resources, we need publications, we need research proving that, and this also gives us leverage in discussions with our clients that this is the right way to go. And ultimately, we need to challenge big refineries and industries putting out kilotons of resources while we farm on like 2 hectares, a little bit of palm oil, rapeseed oil, or whatever. And this is a hard challenge to cover.
And Zia, now I'm going to bring it back to you. Hearing all of that, what does that say to you about the research that you and team have done and where you think you're going to take it next?
Thank you, and thanks for all of your comments. It's really great to hear from you. I think there's 2 ways of thinking about transformative change, and one is you look for the levers and the windows of opportunity within the current system, and you kind of move and shake and you hustle in that system, right? And the other way is like you change the system. And so I think we need both, right? We can't wait around for, complete restructuring of systems. At the same time, we've got very good indications in history where we've seen social revolutions, like civil rights movements. We've seen, individuals, we've seen changes of mindsets where society has made large turns. And it's true, it's a long fight still, but that gives me a lot of hope that we can move towards a net positive climate and, social positive future. So, yeah.
And the positivity is a fantastic thing. Yes, Chloe, something you want to say about that?
Yeah, maybe I could add, I think, especially kind of nowadays in the climate that we're in, sometimes it's also about shifting the narrative a little bit in the language to speak to different audiences. So this is Climate Week, in San Francisco. The audience is. I mean, I can assume what the audience is, but I've just done some research on the right to repair policy on repairing e-waste, for example, for electronics. But right to repair can be a policy that can also be implemented for cars or other manufacturing tools, and that's a policy that can be actually quite bipartisan. And it doesn't only have to be environmental policy; it actually could really also attract other people of different, of manufacturings that want to actually know how to fix their own car and not have to rely on the manufacturing company. So I think that trying to voice policy that can resonate in different audiences is important to also, as evidence and to help and inform that kind of social change that's needed.
Thank you. Speaking of audiences, I would like to give this audience an opportunity to ask some questions as well. We are going to have a microphone that comes around. If you would like to ask a question, please put your hand up. We would love it if you would identify who you are, your name, or who you're working for, or what brings you here today. The panel will do the best job as it can to answer your questions. While you're thinking about if you want to ask a question, I will ask a follow-up. Do we have one already? No, please go ahead.
Hi. I'm Daniel Westcott. I'm working on machine learning for bioplastic formulations, but I worked on a farm for a long time, so that's actually where I'm more interested. The One Straw Revolution really told us about composting, let us understand that systems were circular. Are there other insights from your work that are cut right through the center of the current system that can be implemented on a larger scale?
Thank you. Yeah. So I think as far as we go back in history, right? People have been farming. People have been incorporating ideas of nature in farming systems, right? To recycling nutrients and incorporating pollinators and pest control and all of those things naturally. What we saw, with the Green Revolution was a package deal. And that package deal was fertilizers. It was plants that didn't fall over when you applied so many fertilizers. It was water. It was mechanization, right? And so and then we've seen pesticides increasingly in those systems too. I think, in the 70s and 80s, a lot of ecologists that were like, this is what's unfolding right now is not good, right? And we're like, we need to do more intercropping, and we need to think about composting, and we need to think about these kind of, other kinds of cultures, all the different, cultures in farming, right? But it remained pretty niche, and it remained very kind of like a hippie thing, to be fair, and not even done at scale, right? Even if you look at organics, right? Organics is the one, talking to penetration, right? And everything, and adoption. Organics is the one, alternative that you can put in a bucket, right? That is scaled within the US, right? And still, it's a very, very small percentage of total. But there's been, I think, part of this problem is due to the mindset, and part of it's due to the kind of conversations that are happening in places like the World Bank, the IMF, different government ministries, agricultural development, that can't work, right? And so there's a lot of conversation that can't work, and it's just a hippie idea. But now we kind of have the science that actually is kind of pulling it together to say, this does work, and it does work on these farms, and actually, and it's being published now in the leading journals, which it might not have been 30 years ago. And so I think that's a fundamental change in terms of kind of our thinking. Pulling it through, I think there's very different, there's two different types of challenges that we have, right? One is we have very, very large farms that are very simplified. And the challenge there is in adding diversity. Right, and that's kind of what I was talking about before. It's if you add diversity in those systems, does it improve? And we see examples in the States in field crop systems, right, where there's areas of the field that won't yield very much, where you can add in, hedgerows, or you can add in flower strips, or you can add in these things. There's not a yield hit to the farmer, and that's actually a net gain in terms of water retention, and even when there's shocks and all those kinds of things as well, right? And so, I think that is very different from the transition. There's going to be, depending on the location in the world, many, many farms that are going to go out, right? Farms are going to get bigger. And with that, we're going to lose a lot of diversity. And so the question is how do you maintain that heterogeneity in those landscapes? Now, in other work, what we've shown actually is there are some pretty cool rules of thumb. If you maintain, within a landscape, 20% of its natural habitat, you can maintain pollination flows, you can maintain water regulation flows, you can maintain a lot of these different things. So that kind of might speak to some of those things too. Yeah, thanks.
Excellent, thank you.
Yes,
please.
Kind of a follow-up. I think your remarks probably answered most of my question. I was concerned about monoculture, and Michael Pollan, who's here in the Bay Area, I've gone to several talks. I'm just an end consumer and want to see a more diverse agriculture environment. Do you see any leadership really? I'm just concerned, where is that leadership that really is driving diversity and the end of monoculture in agriculture and the focus on industrial farming?
Thanks. Yeah, I mean, I can see a future where we have industrial farming that is diverse, right? As well. And I don't necessarily, there has to be one or the other, and we need to have, I'm not advocating that we should have small farms everywhere in the world and that, people should stay in farming. I mean, farming is very hard too, right? And so many of the farmers we work with in different continents, they're living in poverty. And there's no way really to get out of poverty with that small half a hectare, quarter of a hectare. As the generations go down, it just gets split up, the land gets split up. And so, there are those challenges too. In terms of leadership, I do think there's a change of conversation right now. And so that was really marked. I mentioned the Food Systems Summit that happened, a couple of years ago, where this is industry and academics and policy makers coming together to try and understand how do we transform food systems so they're better for the environment and better for people. And if you look at the outcomes of that whole year of plenaries and seminars and workshops and synthesis, one of the key things that they said was, we need to diversify our food systems. So I think we're getting there. I do think we're getting there. There's a lot of resistance, right? And this comes to like stranding of assets. But there's a lot that you can do as consumers, and just going to your point of being a consumer, in terms of the public conversation about this. You know, companies will be more willing to strand or transform if it hurts their bottom line, right? So it removes the stranding aspect of it as well. Yeah.
Chloé, would you speak a little bit to leadership as well here? Because you brought up the community aspect, which is really important. Like, you know, some stuff has to come from the top down, but others have to come from the bottom up. Like the community has to ask for it. So where are you seeing the leadership in this right now? Is it more top down, or is it more the community has a stronger voice over the past few years when it comes to issues like this?
I think it really depends on the context. I don't know enough about your field of work, but definitely the communities that I've worked with in Alaska and the indigenous community, like they know their land more than anyone else. They have throughout generations, and they have this intergenerational knowledge of the ocean, of the fish and the walrus and the whales that they eat that are part of their culture. And I think it's more than food. It's part of their culture. We have so much to learn from indigenous knowledge and people across the world. And I think that projects, you know, and I'm sure some of the farmers that you've worked with in your projects are also, you know, small indigenous communities. And I do think it's really important to include them in the conversations, and make those spaces, and I mean, often they don't know about it necessarily. So giving them really the space. And when I say give them the space, is not only to be part of that conversation, it's actually being co-authored and part of the research, and being part of the getting either the data, if done ethically, but being part of that data collection, and then being co-authored in these scientific papers, and actually being really a participant in the process.
Absolutely. Thank you.
Hi, my name is Erica Guys, and I'm an independent journalist and the author of a book called Water Always Wins, Thriving in an Age of Drought and Deluge. And one of the things that I've been thinking a lot about is how in the dominant culture we have a very kind of single focus problem solving approach. I mean, you see that with climate change, like how it's really been streamlined to like carbon dioxide and getting off fossil fuels, which of course is really, really important, but ignores the water cycle, which is also a significant driver of climate, and all the things that might come with that, like conserving land, restoring land health, soil health, et cetera. So I guess just for all of you, when you're talking about trying to make a major cultural shift in a society where we have that real single focus problem solving instead of systems thinking, how do you address that? How do you overcome that?
I'm happy to try and take at least one stab at it, and I'll try and do this as I would in the context of a systems level problem, right? So we've been very focused on thinking about very large scale carbon management. This is not with the thesis that, you know, we've streamlined the problem and sort of tried to think about the focus at hand, but really the answer is the solutions have to be systemic. In fact, you cannot do single point solutions. Let me give you sort of the simplest example at hand, right? So having studied this for over a decade now, we came to the conclusion many years ago that we didn't think that there was a purely synthetic, AKA engineered pathway that would allow carbon management at scale. And we came to the conclusion that, in fact, you know, a realization that coupled with a natural system was almost the only path forward that could work at a large enough scale, but more importantly, quickly enough. And, you know, this is to lead into an example, but we ended up developing a platform that we've worked on for over a half decade now, which allows us to do really large scale carbon removal, but it's based around sort of activating and expanding the capacity of the oceans. It goes back to the water cycle. And the reason for this was really quite clear. We thought that there was a need to be able to sort of, look for, I don't want to call it inspiration, but almost examples in nature, for two reasons. Most things, so the entire engineering profession is based upon doing everything that nature does, but just doing it much, much faster, right? It's not as efficient. Nature's always much more efficient, but nature's passive and it's much slower. What this really leads to is sort of thinking about two things. Systemic responses are important mostly as a function of scale. There's interconnectedness, obviously, that needs to be managed as well. Sometimes you do need to decouple it. And the decoupling is important because it's a question of managing stage, rate, and pace. But the last point that I want to make, which I think is sort of fundamental to this, I think it really comes back to time. I think it's relatively clear as things stand that we probably have no more than about 15 years to make a very large difference at a very large scale. We can argue about the carbon budget and how many ways we want to split that, but I think 15 years is a pretty strong number. I trained to be a civil engineer. And why do I think about 15 years or 20? We can be generous if we so wish. For us to build any large capital project today, right? So think about things like refineries or maybe not the Bay Bridge because that took 2 decades. But if you think about a capital project, these things take at least 5 years to build. If you imagine needing to do global build-outs of very large scale infrastructure, it's not going to happen quickly enough, which means you have to couple toward a natural system because that's your activation point. But that really brings back the commentary to why systems level impact and action really matters.
Good morning. Okay. Good morning. Thanks for being here. My name is Keith Chris. I run a little studio, creative guy, and I would say thank you for putting together a really great presentation, since my world is involved with good communication. And I was thinking, how do you communicate beyond the choir? We're sort of the folks that all kind of are here. We kind of agree and have a lot of affinity for what you're doing. But how do you speak to those that are on the fence, or the naysayers, and be a good communicator, visually? And so, have you considered maybe having a Planet Prize to help people develop ways to speak to a wider audience, to help tell the story, to communicate what's going on in Alaska or elsewhere, the struggles you're having, and trying to just be a darn good communicator?
Thank you for that question. I think I want to start with you, Arthur, if you don't mind, because having been involved with 3 startups, you have to have the elevator pitch down cold now. So I'm not asking you to give it here, but I think you have a very interesting real-world experience of how do you get complex ideas in front of people in a short amount of time and get them to buy into that idea.
I think from the client perspective, the easiest way is certifications. There are plenty of certifications. How much you trust in them is another point. But if they are in place, you are already way ahead of competitors maybe. On the other hand, certifications are not that cheap. They take some time. In our field, we develop new materials kind of every day, and we would need to certify every one of them. So when it's not certified, we are limited to the communication based on published literature, on the science, on our internal research, and also on third-party paid experiments. And this is transparency is the key to that. And the more information we have, the better. On the other hand, we still need to rely that the counterpart is trusting in what we are disclosing here. And that's the main, it's a kind of a circle we are always circling around.
Yeah, it ties into the push for open science. If you can find these things, they won't always trust it if it comes from you. But if they can find it themselves, if it's easy to find themselves, maybe they'll believe it more, even if it's exactly the same information. If they feel like they're getting it themselves, not it's being handed to them by some group or they had to get access in a certain way, sometimes that same information is more believable. It's odd, but it's true.
Totally.
Yeah. Thank you. Sir, you had a question.
Yeah, my name's Ryan Hartnett. I have a background in tech, but in the last couple of years, I've become an entrepreneur and a startup and an evangelist for this particular solution to the climate crisis. I have taken the approach of human-included ecology as kind of the core concept, and looked at different models for making the transition from monocrops and artificial inputs to natural systems. I have 2 organizations now that I'm working with. I'm working on resurrecting a 501(c) or nonprofit to build communities that would support the biodiversity required to implement these systems. So my question is, as a solutions path to transition, what are the leading models? Because I think and what's the scale that a human-oriented ecosystem would need to operate at to be competitive with the large-scale, maybe automated systems that might come out of the large farms that are operating now? What are the pathways to this transition that you see, and what do we need to have multiple versions be viable both in that?
Thank you very much. What do we?
Yeah, thanks for that. I'd love to chat more. It sounds like fascinating. Yeah. I think, just to kind of talk to one of your points in humans in agricultural systems, right? And so if you look, there was this spread in National Geographic in the 50s. There was a futuristic spread that showed like what agriculture would look like in the year 2000. And it was like this kind of like, very like planes flying across and dropping pesticides. And there was a farmer sitting in this kind of like, almost like a penthouse, with robotics and kind of like, controlling these things. And you had these concentrated animal feeding facility, high rises and things like that. And some of that's come true, right? And everything. But I think your question is humans out of these systems, right? How does that impact us? And we've seen that definitely impacts us. Like children in cities that have access to growing food, that has a profound impact on them, right? On how they consume, has an impact on their well-being, many different things. There's a farmer we work with in Iowa, and he grows an organic farm, and he has all these flower strips, and the flower strips provide pollination. But you ask him why does he do it, and it's because when he goes outside, it brings him a lot of joy, actually, to see all of them, And so I think there's these elements that we kind of losing when you take humans out of the systems. But if you want to maintain, there needs to be, and coming back to like Chloe's point, there needs to be, human rights needs to be center of that. And actually, when you look at the agricultural workforce in the United States or other places across the world, they're devalued, they're exposed to, harsh chemicals, they are out in the heat. We've done a bunch of modeling looking at, heat stress and things like that. Actually, if you look at the policy, many of the national adaptation plans don't even include workers in climate policy, in the national adaptation plans of countries, in terms of climate and stress. So we need to actually think about human rights, is what I'd say, to actually try and get somewhere towards your vision. Yeah.
Thank you. Let's take. Oh, I'm sorry. Go ahead.
There's been a question there from the beginning.
Oh, okay, very good. So let's make sure we get that, and then let's do that one, and let's do then, because I'm cognizant of time, one more question after that. And then I would like all of you to be able to make a closing statement if you would like, just to make sure you get to say what needs to be said. Please.
Yeah, hi, thank you. This has been a fascinating session. I'm curious, and I think this is really 2 questions that I'm going to lump together. One is, we talk about the need to transform agriculture, but how does that look when we look at, for example, a situation like the United States or Europe, where there tend to be large, highly intensive farming operations versus developing countries where they are more mixed? That's the first question. And then looking at countries like the United States, where food has become dramatically, and I think inappropriately, cheap, in part because of the abuse of workers, in part because of the mechanization, in part because of the homogenization of crops. So you've got an economically efficient system that is driven by an expectation now for cheap food that looks good. If you look at the Red Delicious apple, it's an example of a food that killed itself because it went from a really flavorful thing to a thing that looked really good, but was mushy and indifferent. So I'd appreciate comments on those thoughts or suggestions. Thanks.
Thanks, yeah. Chloé, when we first met earlier, said, "Oh, I read your paper," and I was like, "Wow, no one ever reads the paper." But I think you should go read the paper. I mean, I think there are many examples where we have actually in Northern American systems and in European systems where farmers are increasing diversity in those systems. There are actually countries that are taking the lead on this as well, like France in particular. A lot of mandates around use of pesticides, which has driven. I've been to these research stations where researchers are intercropping plants in ways you would never seen before, and things driven by the regulation around pesticides. And so I do think there is evidence for change in Northern America and in Europe too. On the kind of cheap side versus expensive side, I mean, this is a very kind of, it's almost a question for Gaurav as well, right? Like on kind of the engineering. I mean, when I come from Europe, food is very expensive here and it doesn't taste very good. So it's like the worst of both worlds, actually, right? But I don't know if you have more kind of thoughts on that, like how you how you deal with that problem. But there's a lot of friction and there's a lot of lobbying and there's a lot of subsidies that are in the wrong places, right? I think that's part of the problem too. Yeah.
I could maybe just add on that. I think often we think of regulation as being potentially a bad thing. A regulation can also create new business opportunities. So if there is a new regulation, a new mandate to ban pesticides or to ban something, then there's maybe opportunities for startups to come and create new ventures. And again, that's talking to different audiences, or for the scientific community in the room, or researchers, like, think out of the box. Think, okay, this is the situation we're in now. How can we use our knowledge and data and research and think outside of the box? What are the regulations that I could be part of the room for the rulemaking because there's a public comment period in my tiny little local jurisdiction or a little bit statewide jurisdiction? Like, be a little curious. Look around what's happening in your own community or in the community of your neighbor's community. A lot can be done at a local level as well. And I think policy is an important space that can be very inclusive and often is under, it's not in the headlines that there is a comment period for a particular regulation in your particular research area or interest area, because you also don't have to be a scientist or I'm a lawyer by training, but I'm here talking to really impressive scientists. So. Thank you.
Hi, I'm Gus Harput, and I'm a startup founder in reusable packaging, but I am also a small organic farmer in Oregon, where I live part-time. The question I have is, how do you reach out and help us farmers gain more expertise or help in becoming more natural and organic and sustainable and stay in business?
Thanks. Yeah. The way that we have worked as a lab in general is through partnerships. So we partner with, we know we can't do everything. The United States is actually, and actually in Europe too, we've seen there was a lot of funding that went into extension, not just for ag, but for forestry and resource management in the 80s and things. And then in the 90s, it just like dissipated. And then, private companies came in. And then you ended up having extension being provided by your fertilizer companies or your seed companies, right? And so we're kind of in this situation right now. But our mode of working is through partnerships. We realize that individual we can't actually scale. So what we do is we work with farmers who work with networks, right? Or researchers that work with networks. And so that's our kind of approach. And through that network effect, I think you see change. So we actually looked at, as part of this broader research that I presented today, we looked at the structural factors that are limiting diversification or limiting, the uptake and adoption of these kind of practices, right? And what we found was that the farmers that were doing it in different places, even in the Midwest, but in Brazil and different places across the world, the way that they managed to do it is through these networks kind of effects. So even with these kind of structural constraints, building networks can be very, very powerful to doing that. We also work with kind of farmers organizations like the National Farmers Union and Moses, and in Canada, the Ecological Farmers of Ontario, right? So those, we work with those networks too, and that's how we kind of propagate out. Yeah.
Thank you very much. We have to move on, but I hope you'll be able to stick around and speak with the panel afterwards while you're having another coffee or something else with us. Just wanted to give the panel a brief moment to wrap up. If there's something we didn't get a chance to talk about or something you want to make sure that you have an opportunity to say, the floor is yours.
Well, I'll say a little bit. This isn't the best audience, but sort of to make a comment which I think is important on network effects, right? There's maybe 2 or 3 comments for me to point out. First, being in San Francisco and saying this is San Francisco makes a lot of sense. I think it's important to understand that climate change and sort of most of the things that underpin the mitigation of climate change are all problems of atoms and molecules and not bytes. There's this great thesis that we seem to have unleashed into the world that software will save us. Software will definitely help us, right? Made our lives a whole lot better in a variety of different ways, but it's not going to solve the underpinnings of the challenges that we face. I think that's the first comment. And another thing which I think is sort of important to reflect on is just like most of us have now got, the attention span of a fruit fly. We're all caught up in some sort of a news cycle, new information flow. One of the fundamental challenges that we face is providers of capital are all super impatient. They want a massive return on investment and they want it in a really short period of time. For anyone that's done anything, in some half sense in the real world, you realize that there are some major dislocations between our desires and our pathways and processes of trying to achieve them. I think it's important to sort of have an honest conversation around these things, because these dislocations only expand. And the expansion of these dislocations actually takes us further and further away from goal and creates a hype cycle that you don't fulfill. And this has nothing to do with engineering, right, obviously. But it's something that, we've been studying for quite a long time because we care about technology flows. And we're starting to see that there's some major challenges to the creation of underpinnings of new technology because we don't have neither the capacity, financial, nor the patience, nor frankly, an underlying thesis that allows us to get there. So, bit of a Debbie Downer note, but there has to be at least one Debbie Downer in the room.
We'll have coffee to perk ourselves up, no worries. Anyone? Anyone else? We feel like we're all sorted? If not, I will hand the floor back to Amelia, and I would like to thank you all. Please, a round of applause for our wonderful panel.
Thank you very much, everyone. I started by saying science or coffee, so we had a good moment to talk about science. Thank you very much to all our panelists. We can see how important this dialogue between advocacy, science, and community is. I hope we could also give a message of hope, saying that it is a difficult time for science, it is a difficult time for climate change, but it's also a moment where communities and people get together, and I guess it's a good moment with a good call for action. With that, thank you very much to Frontiers for organizing this together. It was a pleasure. Thank you to Climate Weeks. This is the closing event of Climate Week. I hope you all had an amazing week with a lot of inspiration. And I invite you now to mingle, get a coffee. Thank you so much to our coffee people over there doing an amazing work. And wish you a great day. Thank you.